Hello everybody. In a previous video we demonstrated how to configure inter-VLAN routing using the router on a stick technique. In this video we will take it up a notch and we will get to configure inter-VLAN routing using the router on a stick technique once more, but across multiple switches. We're going to configure 3 VLANs, VLAN 10, VLAN 20 and VLAN 30, and each one of these VLANs will correspond to a different switch. So with that said, let's pick the 2960 switch and create 3 copies of it, like so, and create a 4331 router, which we're going to place at the top of our topology. Next, we're going to create 3 PCs, with each PC residing in a single VLAN. Next, we are going to install the necessary network media. So a copper straight-through cable between the first PC and the first switch. We're going to use the first Ethernet port for that. Same for the second PC. Same for the third and last PC. Okay, and for the interconnectivity between the switches, we will have to use a copper crossover cable using the last fast Ethernet port, 24th. For this one, we're going to use port 22 for the middle switch, 23 against the 24th port of the last switch, and then finally a copper straight-through cable from the gigabit Ethernet 0/0/0 interface of the router to the last fast Ethernet port of the middle switch. We're going to fast forward the time and we will get to configure each switch in turn. So the first switch is using the last Ethernet port of 24 as a trunk port and the first one as an access port, and our configuration is going to reflect that. So we will navigate to the CLI and run enable conft interface fast Ethernet 0/1 switch port mode access, switch port access VLAN 10. Oh, actually VLAN 10 doesn't exist, so let me do that first. So VLAN 10, name IT, exit out of there and then go back to fast Ethernet 0/1 mode access and switch port access VLAN 10. Perfect. Next we will go into fast Ethernet port 0/24 and make it a trunk port in order for the switch to be able to pass VLAN related information through that port. And we are done with our first switch. Show VLAN brief. Perfect. Okay. Next, we will move over to the middle switch, which is the most complicated one. We will fast forward the time and let's check. This port is 22 and this port is 23. So 23, 22, and they should be 24. Okay. So enable conft VLAN 20, name it sales, and then interface fast Ethernet 0/24. Make that a trunk port. Fast Ethernet port 0/23. Make that a trunk port as well. and interface fast Ethernet 0/22 switch port mode trunk. Okay, and should be the first port connected to that PC, indeed. So we will do interface fast Ethernet 0/1 switch port mode access, and then switch port access VLAN 20. Okay, now this middle switch also needs to have knowledge of all three VLANs from the other switches as well. So far we've created VLAN 20, but we haven't created VLAN 10 and VLAN 30. So we will do VLAN 10, no need to name it again, and VLAN 30. And we should be good to go with our middle switch as well. And next we will configure the third and final switch. Just before I do any configuration, I will confirm that the trunk port is going to be the last fast Ethernet port, whereas the access port is going to be the first one. So enable conft VLAN 30 first of all. We're going to name it finance, and then we will do interface fast Ethernet 0/24 switch port mode trunk, and then switch port, interface fast Ethernet 0/1 switch port mode access, and then switch port access VLAN 30. And then show VLAN brief and show interfaces trunk. Alright, perfect. With the configuration on the switches complete, we now need to take care of our router. So we'll navigate to its CLI, type no, and then do enable conft, and then we will go straight into the gigabit Ethernet interface of 0/0/0.10, which is going to be the sub interface that will correspond to VLAN 10. We will do encapsulation.1q, which is the protocol used for VLAN tagging, followed by 10, which is the VLAN 10. Then we will do IP address, and we will give it an address of 192.168.10.1 and a subnet mask of /24. Finally, we will do a no shut. Same thing for the second sub interface 0/0/0.20 encapsulation.1q 20, and then IP 192.168.20.1 with a /24 subnet mask. And no shut. And last thing with the third sub interface. So 0/0/0.30 encapsulation.1q 30 and IP address 192.168.30.1 and 255.255.255.0 as the subnet mask, followed by no shutdown. And we will go into the parent, let's say, interface /0 and run a no shutdown there too to bring them all up. And that's everything we need to do on the router side of things. So all that's left is to configure the PCs. So IP configuration for the first one, that is part of VLAN 10. 192.168.10.10 is going to be its IPv4 address. The subnet mask of /24 is the right one, and .1 is going to be the IP address of its default gateway. Same for the PC of VLAN 20. IP configuration 192.168.20.10, subnet mask of /24 and .1 for the default gateway, and finally our third PC 192.168.30.10 is going to be the IPv4 address of this PC. /24 is going to be its subnet mask, and .1 is going to be its default gateway. So that's done as well. So with all this in place, we will fast forward the time, and in theory all PCs should be able to communicate with each other. So I will run ipconfig on the PC of VLAN 10. We see that it has the IP address of 192.168.10.10. So let's ping 192.168.20.10, which is the IPv4 address of the PC of VLAN 20. So we're pinging the host, no feedback, request timed out is the first response, but then the subsequent 3 are all successful. What if I try to ping 30.10 or VLAN 30? No feedback. The first request fails, but then once more the subsequent 3 succeed. And if I do it again, we have no issues whatsoever. Similarly, if I open the PC of VLAN 20, should be able to ping 192.168.10.10, which I do, as well as 30.10, which I do also. And let's test out the PC of VLAN 30, ipconfig. We can see it has an IPv4 address of 192.168.30.10. So can I ping 192.168.10.10? I can. And what about 20.10? I can indeed. And so there you have it. We have successfully configured inter-VLAN routing in a router on a stick deployment across multiple switches.